Hello again everyone, welcome back to ptet.chemistry channel. So this will be a topical MCQ on atomic structure topic. So radioactive decay is to do with chemistry of the nucleus of an atom. So it's been a long time since a question has been asked on radioactive chemistry in A-level chemistry essentially. But if you look at the periodic table, lead going to bismuth. So looking at the proton number, we're looking at element 82 to element 83. So there's an increase in proton number. So that's why you have X minus 1, 0 there. So that is associated with the nucleon number. And this is associated usually with the atomic number or the proton number. Okay. But the fact that you increase in a proton there, okay, that's why this is not a proton. As you can see, there's no nucleon number there, meaning there is no proton and there is no neutrons, because those are the species present as the nucleons in the nucleus of an atom. Since it is not a proton, since it is not a neutron, therefore it has to be an electron. Okay, so that's just basically the idea on nucleon number. Moving on to 2a part 2. This is a question on finding relative atomic mass. Instead of being given percentage, you get a relative abundance. So that's why you are not going to get something over 100. You need to be very careful. So here essentially we have copper. So we have copper 63 and we have copper 65. The relative abundance of 63 is 7. The relative abundance of 65 is 3. So the relative atomic mass is going to be the mass number times the relative abundance plus the mass number times the relative abundance divided by the sum of the relative abundance. Okay, so the use of bracket is quite important in order for you to avoid making any mistakes. All right, and it's easy to check your calculation as well. So 636 over 10, that is equal to 63.6 there. As you could also see, the value is quite close to 63 compared to 65. The middle point is 64, but this average is closer to 63 because you have a lot more of the 63 than the 65. This is the abundance of the isotope, okay? And this is relative atomic mass, which is the average mass. So moving on to the next question. So this one is about which one has the largest radius. So we have to think about the number of field shells, the electronic shells, yeah, okay. So when you look at the configuration, the electronic configuration, the P3 minus is a third period element against 3 electrons. Is going to have argon configuration, same as that, same as argon. K plus is in the fourth period. Sorry, K is potassium, is in the fourth period. But when you lose an electron, you're going to have the configuration of argon as well. So in terms of the number of electrons, they all have 18 number of electrons. So we are just looking at the difference in the number of proton. So there's 15, there's 17, there's 18, there's 19. So remember, we are talking things about effective nuclear charge, which depends on your nuclear charge, which is the charge of the protons in the nucleus, and then it's got to do with shielding. Okay, in terms of shielding, because they all have 18 electrons, the valence electron occupy the third shell anyway. Okay, there's the argon electronic configuration. So in terms of shielding, they are not too different, but in terms of nuclear charge, they are different. As you could see, the number of proton increases. Okay, so in terms of the same number of electrons, since there are more and more protons in the nucleus, your effective nuclear charge gets stronger. When your effective nuclear charge gets stronger, your valence electrons are pulled closer together. Imagine they are being attracted more to the nucleus and therefore smaller size. Okay, so these are ions. Okay, it gets smaller. These are atoms. Okay, but in terms of the largest radius, is going to be A, because of this trend where we say Z effective increase. So this is the weakest Z effective, and therefore this is the one with the largest radius. 2a part 4, this is saying that aluminium and the transition element require the same amount of energy to form 1 mole of an ion with a +2 charge. So I hope you imagine that aluminium, you have, when USD is talking about the ionization energy, okay, and it say use the data booklet. So this is quite specific to the data booklet. They will be given out as part of the Cambridge International Exam. A lot of chemistry students during the UK A-level will have access to the data booklet as well. The value might be slightly different, but they won't vary too much. Yeah. So in order to go to Al2+, you will go stepwise like that, and then you will go another time. So overall, there's your first ionization energy, there's your second ionization energy. So from there to there, you will have first plus the second ionization energy. Okay, so they're saying that the same amount of energy for that transition element to form the ion with +2 charge as well. So you got to sum up the first plus the second ionization energy from the data booklet. Okay, so my data booklet shows me, if I go to the transition metal, cobalt, it shows me 757 plus 1640, so it's 2397 kilojoule per mole. This is for aluminium. Aluminium is 577 plus 1820. So really it's just looking at the question, and already the first option already give me the exact same one. So really that's the answer already. Okay, you could work out the rest, but you could see that you already got the one where the first and the second ionization energy sum up to the same value. So it's going to require the same amount of energy from the atom itself to form the +2 charge cations. All right. So in this question 2a.5 is asking about a free radical of chlorine. Okay, so a free radical is a species with unpaired electron, and you will do more of this once you have covered organic chemistry in AS, typically under free radical substitution reaction. Okay, so it's a chlorine atom. It's actually a chlorine atom. Okay, when you think about 35 chlorine dot, is a chlorine atom with an unpaired electrons. So it has 1s2, 2s2, 2p6, 3s2, 3p5. So if we just look at the p subshell, it's got 1, 2, 3, field parallel spin first, 4, 5. This is your unpaired electron. Okay, so the atom itself has unpaired electrons. That's why it's called a free radical. And atomic configuration says that chlorine has a proton number of 17. That is unique to the element itself. Very unique, yeah, element number 17, because element number 18 would have been argon. All right. Neutrons, you are talking specifically about this isotope, so that is the nucleon number. Therefore, the number of neutron is equal to 35 minus the proton number. It's going to give you 18. So no difference there. In terms of the electrons, do you see how this radical, it has no charge? If it has no charge, the number of proton equal to the number of electrons. Since you have 17 proton, it must be 17 electrons as well. Okay, so this is the quite a short tutorial video. So we just cover 5 questions in each topical MCQ video. So I'll see you in the next video. Don't forget to subscribe if you like my teaching style and my explanations, and drop some comments if you have got any. Okay, see you in the next video.